All right, so here we have a visual of some of these terms. So let's start. Let's see, turning points. So the turning points are all of these right here, right? These are all turning points. Okay, the zeros right here, those are all the x-intercepts, right, or the roots where the graph crosses the x-axis. Also where f of x equals 0, right, or where y equals 0. Okay. Yeah, so then that's synonymous with x-intercepts right there, right? Those are the same. End behavior. So end behavior is what happens on the end over here. So like here, the end behavior, you'd say as x approaches infinity, y approaches infinity. Okay, so basically like you can say as it goes right, it goes up or something like that. It goes up and to the right forever. And then you could say that, the kind of the counterpart down here, as x approaches negative infinity, you can write it like this. X approaches negative infinity. You can say y also approaches negative infinity, right? So as x goes to the left, y goes down, right? So that's another way to say it. All right, so that's end behavior. Okay, and then we have y-intercept. We know that one, right? That's where it crosses the y-axis. Okay. Now here, the degree and leading coefficient, we'll talk about that in a little bit, but basically the end behavior can tell you the degree and the leading coefficient. Okay. And actually, let me just, I'll just give you, let's actually look at the next slide and then we'll figure it out. Okay. So these are some different polynomial functions, and not necessarily the parent functions, but just kind of some examples, right? So we know degree 0. So if you have x to the 0 power, that's a constant, right? You don't actually see the x because anything to 0 power is 1. So constant function, remember, that's just y equals a number. We'll put y equals b. Okay. All right. Then you have a linear function, which is a diagonal line, right? And notice it goes up to the right, down to the left, the parent function, right? So this is degree of 1. So usually we have these y equals mx plus b, right? So that's a first degree because it's x to the first power. And then quadratics is a degree 2. So here's where we have ax squared plus bx plus c, what we've been working with in the whole chapter 4. And so when you have a squared exponent, then you see that parabolic shape, right? Notice how it goes up on both sides. All right, so cubic, the next one, degree 3, that's a cubic. And so that's where we have y equals ax cubed plus bx squared plus cx plus d. And so notice how it goes up on one side, down on the other, right? Okay, then you have a quartic. I'm not going to draw it out, but you can imagine it be ax to the 4th plus bx cubed plus cx squared plus dx plus e. And then degree 5 would be a similar, right? Ax to the 5th plus bx to the 4th, etc., etc. Now, so let me just put here, the first term is ax to the 4th. So you don't necessarily have to have all the terms after it, but you do have to have, the highest power. So the highest power here for a quartic would have to be a 4th power. Highest power for a cubic would have to be a 3rd power. Highest power for a quadratic is a 2nd power. Highest power for a quintic would be a 5th power. All right. Okay, now let's look at the patterns here. We talked about end behavior. So let's ignore degree 0 for a second. But what do we notice about the even functions and their end behavior versus the odd functions and their end behavior? All right, and if you said the evens go up on both sides, that's exactly right. Okay, so even, so if they go up on both sides, then it's even. If they go up on one side, down on the other, it's odd. Okay. So I have a slide right here that kind of shows some of that. It's a little bit hazy. I thought it'd come out a little cleaner. Just found this on Google. But anyway, so even degrees either go up on both sides or down on both sides, right? Whereas odds go up on one side, down on the other. Up on one side, down on the other. Now, which side they go up and down on depends on the leading coefficient. Just like with a parabola, remember, if A is positive, it faces up. Same with these. If you have a positive leading coefficient, so in other words, if A is positive, then it's going to be going up and to the right. Okay. And so in the case of a even degree, it's going to be going up on both sides. In the case of an odd, it's going to be going up on the right, so that means it has to go down on the left, right? If you have an odd degree polynomial, or excuse me, if you have a negative leading coefficient, I should say, then it's going to go down on the right. Okay. If it's even, that means it's going to go down on the left as well. If it's odd, that means it's going to go the other way on the left, which would be up in this case. All right. So that's how you determine by looking at the graph whether it's an even or odd degree and whether it's positive or negative leading coefficient. Okay. All right, now back to this one. The other thing you can tell by looking at a graph is you can tell what the minimum degree is by the number of turns. Okay, so let's count the turns. So with the quadratic here, we had degree 2, we have 1 turn, right? With the degree 3, we have 2 turns. With the degree 4, we have 1, 2, 3 turns. With the degree 5, we have 1, 2, 3, 4 turns, right? So how many do you think we'd have for a degree 6? That's right, 5 turns. How many turns could we have for a degree 10? That's right, it would be 9. Good. So the number of turns you can have is one less than the degree of that polynomial. Okay. Now, just to let you know, a quartic function can also look like a parabola. So it doesn't have to have that many turns. You could just have 1 turn, right? Or with a quintic or a cubic, sometimes they just look like this, where they actually don't go from positive to negative. They just kind of do that little wiggle. And so that could happen too. That's actually what the parent function looks like, is something like that. Okay. All right. So anyway, so because it's a degree 5 doesn't mean it's going to for sure have 4 turns, but that's the most amount of turns it can have. All right.